Let's just go through a couple of terms here. Rational expressions, which we've defined. Any value that must be excluded for a variable is a restriction. Because you now have a denominator, there is now the possibility that you could have a variable that becomes zero, which means that you cannot evaluate this expression. You cannot divide by zero. If you take your calculator now and try to divide anything by zero, it blows up. Well, I'm being extravagant. It doesn't blow up. It just gives you an error message and says, I can't do what you're asking me to do. So that value that causes your expression to become undefined is referred to as a restriction. So you look at the denominator for that, right? Anything that makes that denominator zero is what is your restriction. So let's take some restrictions here, right? What restriction would I have on the variables in A, right? What value of A would I have to say you cannot use because it causes my expression to blow up? That's Mr. Kamak's term. Don't use that if you're in any other context because that's not the technical math term. Yes, B cannot be what? B cannot be zero. So we write that by saying something that we did a few days ago when we were talking about domain and range. We just put B cannot be zero. That's your restriction. If you're asked for restrictions, you write it like that. Some value of the variable is not possible, is not usable, because it causes the function to blow up. My term, not the technical math term. That's my restriction. Look at B, right? If I gave you B and I said, what value of the variable or variables will cause a problem? What value would you suggest that is? Switch here. 3. If I were to make y 3, this blows up because I'm going to have 3 minus 3, which is 0. Doesn't matter what x value you have. You can have any x value you like, but your y cannot be equal to 3. That's your restriction. That's the thing you have to be careful about. That's a number that you should avoid using. Look at C now, right? It's x over x minus 5, x plus 3. What restriction should I be careful about now? Yes, AJ? Restrictions right there, if you just heard what AJ just said. There are 2 restrictions this time. X cannot be equal to 5 or minus 3. Those are 2 values of x that would cause my expression to become undefined. And that is why we call them restrictions. You're saying use any value of it's like asking for the domain. Use any value of x that you like, but don't use those. Those are off the table. Those are prohibited. And that's what a restriction is. So if I ask you for a restriction, as I will as we go through this, that's how you state your restrictions. Okay. Now let's simplify some rational expressions. And we're going to start off with stuff that you're familiar with because you just finished doing this. Reduce to the lowest terms. The first one is easy, 2 over 4. That's 1 over 2. I'm not going to spend any time on that. Minus 8 over 12. That's easy. Divide the top and the bottom by the common factor, which is 4. 4 into 8 gives me minus 2. And 4 into 12 gives me 3. So minus 2 over 3. But how about these? Now we have some variables. There are no restrictions here. A and B had no restrictions. It says factor the numerator if possible, factor the denominator if possible, reduce the lowest term, state the restrictions. The first 2 have no restrictions because there's no variable in the denominator. So you can't even assign any other value than the values that are there. They gave you the values. Those are all constants. Constants means they don't change. But in this case, we have variables. N to the power of 3 over n to the power of 5. This takes you back to your work with exponents to figure out how to reduce this. Can anybody tell me what this looks like in its lowest terms? N to the power of 3 over n to the power of 5. Yes. When they have a same base, the rule is for exponents, if you remember this, Satuzan, that when they have the same base, which is in this case n, that we subtract and you're dividing. You subtract the exponents. Does that ring a bell? Okay. So Nakib is right. That's equal to n to the power of minus 2, 3 minus 5. But I should also say that there is a restriction. Well, you might say, well, let's just ask about that. What value of n is a problem? Right? You have to go back to the original, by the way, to answer that question. Right? Look back at the original. What value of n would have caused us to have a problem? Yes. 0. N cannot be 0. So you also have to say n cannot be equal to 0. Here's your restriction right there. That's the value of n that we have to disallow and say, no, you can't use this value. Right? You can use anything else you like, but not 0. Look at the next one. M squared over m. Think about what Nakib just said a few minutes ago. Yes, Jay? What's that? Just m. Because what you're doing is what Nakib just said. You subtract the two exponents. So it's m2 taking the 2 and minusing the 1, which gives us just simply m. But again, what value of m is disallowed? What value of m is restricted? Yes, 0. Thank you, Naomi. M cannot be equal to 0. Well done, folks. We might look at this and say, yeah, but when I reduced it, it was just simply m. So why should m not being 0 be a problem? Well, because it used to be a denominator. So always go back to the original expression and ask the question from the original, not from the reduced. Great. Great. Let's move along. Well, a lot to get through today. Simplify and state any restrictions. Uh-oh, now it gets a little bit harder. So how did that happen? Simplify and state any restrictions. Okay, so one of the things you saw on the previous page was to factor if possible. That goes for the top and the bottom. That goes for the numerator and the denominator. So look at that numerator and see if you see any common factor between the terms in the numerator. Is there anything that's common there? Yes. Yes. So we can what's called factor it out. So this is equal to x bracket. We're going to divide the other two terms that we have by that x and put that inside the bracket. That's how you factor. Remember factoring from grade probably 9? Okay, so I'm dividing this by x and that by x. So what's 5x squared divided by x? Yes, Jay? That's 5x. And how about the minus 3x divided by x? You had your hand up a few minutes ago, a few seconds ago. How about the second one? How about dividing this also by x? What's that? Close, but it's not positive 3 though. It's negative 3. So we've factored. And it's still over x. That doesn't change. Right? We're still dividing by x. But now we can try to see if we can reduce it. Can we reduce this is the question. Any ideas on how we can possibly reduce this? Come on, folks. I see some hands all the time. Yes, Gary. Divide both the top and the bottom by x. Yeah, absolutely. Absolutely. So what will happen is I do x into x, which gives me 1. X into x, that gives me 1. I'm just left with the 5x minus 3. Right? Both of these, that's 1 times this, which is just going to be 5x minus 3. And that's just 1 on the bottom. So just 5x minus 3. But again, there are restrictions. They might look at this and say, but 5x minus 3 doesn't have any restrictions. It doesn't have a denominator. There's no problem here. No, there's no problem with that. There was a problem with where we started. And that's what we need to always focus on. Go back to the starting point, right? That's where you need to look to see if you have restrictions. If I go back to the starting point, what's the restriction? What are the restrictions if I go back to the start? Okay, thanks to both of you. Looks like you're about to put your hand up over there, Shreyash. You're I can kind of see the half commitment there. Like, I might know this. What do you think the restriction is? X cannot be 0. Absolutely. Thank you very much. And remember, x cannot be 0, not because of the 5x minus 3. X cannot be 0 because I was dividing by x in the first place. Focus on the denominator to know where the restriction is. What is it that would cause a problem at the very beginning? That's what my focus needs to be on. Good stuff so far. Okay. Next question. This one, it gets a little bit more involved as we go along. But let's just remember what we said 2 pages ago. Let me go back 2 pages. Top of the page. It said, factor the numerator if possible, factor the denominator if possible. I would say it is absolutely possible in this case. So, help me to factor the 2x squared minus 10, and help me to factor the 4x minus 2. Yes, Abel? Yeah. Good. Would be what? Good. Everybody hopefully accepts those 2 factors. Okay. I need some help now. Emily, I think it is. Emily, do you agree with the 2x, by the way? Does that make sense to you, that the 2x is the common factor? Okay. So can you do this for me now, please? I'm going to start calling up names because not everybody is volunteering. So that's when I get the seating plan and start going wild with names, all right? We're going to have to restrain me at this point now. Divide both of those by 2x. And we're going to put what do you get inside the bracket because that's how you factor, all right? So divide it by 2x and tell me what you're going to get. You're going to get x. Well done. Thank you very much. Rosie, I need your help now, please. I was told that 4 was a common factor. Let's divide that 4 into both of those and try to factor the denominator as well. Go ahead, please. X minus 5, okay. Okay, so do you see why we did that now? Do you see why that might help us to reduce this thing down some more after we factor it like that? What do you think, Kathuza? What's that? Yep, we can cancel out the common factor, can't we? So we can divide this by x minus 5 and this by x minus, leaving us with 1 and 1. Always leaves it with 1 when you reduce it down like that. But we can reduce something else. We can reduce something else. We certainly can. Angeli, go ahead. Say it again. True, because what we're going to do is we're going to also reduce the 2 and the 4. So 2 goes into 2 once, and 2 goes into 4 twice. So we're going to try to reduce this as much as we can. So what's left on top? I have a 1, an x, and a 1. That's it. On the 2, I have a 2 and a 1. So what we just heard from Angeli is that this actually works out to be x over 2. That's all that's left. Okay. Thank you, Rosie. Let me see if I can get some help now from Atifa. How about restrictions, Atifa? What value of Is it x? Yeah. What value of x do you think would have caused a problem right from the beginning? Right? Not where we are now, because right now, this is just x over 2. Right? There's nothing that x cannot be. But there was some values of x or value of x. It would have been a problem up here. Can you think of what that value is or values might be? Well, let's put 0 and see what happens. If I put 0 into that, I'd have 4 times 0, which is 0, minus 20. So 0 minus 20, oh, that's fine. I can divide by minus 20. So 0 itself would not be the issue here. Do you see what I'm saying? Plugging in x as 0 is not a problem. But there is a value that would be a problem. That's what I want you to think about. Thanks, Brody, for putting your hand up. I appreciate that. What value of x, and let me give you a, oh, I'm asking you, yeah. 5, there you go. If you look at the factored form, there's a clue right there, right? Because if I put as 5 into this bracket right here, I'm going to get 5 minus 5, which is 0. 0 times anything is still 0. That's why 5 is a problem. Now, the other way that you could do this, not just for TIFA, if you're trying to forget the restriction, a little box on the side here, take that denominator, 4x minus 20, and set it equal to 0. What you're really asking is, what value of x would have made this thing become 0? If you solve this, you get the answer for the restriction. So how do I solve that? Put the 20 on the other side. 4x is equal to positive 20. Divide by 4. Divide by 4. And x is equal to 5. So my restriction is that x cannot be equal to 5. And there you go. That is the restriction. Thank you, Atifa. So it reduces to x over 2, but the restriction is that even though we could put 5 into this, in the reduced form you could put 5, but you couldn't put 5 into the original. That's why it's a restriction. Okay, I think we're doing okay so far. Whoa, it doesn't get any easier, folks. It does not get any easier. All right, let's just take a breath. The instruction said, factor it if possible. And I'm saying that is possible here. It absolutely is possible. Yes, Jay? A 3 and a out of the top. We'll do that. I like that idea. But now we need to figure out what the factor, well, tell you what, let's stick with the top for now. When you take that 3m and you divide it into the two terms that are on top, what are you going to get? That's the question I have for Sahil. Yeah, Sahil. You're going to get, sorry? Well done. Well done. How about that denominator? How about that denominator? Akifa, can you help me out with that? Can that be factored? No? I'm going to have to disagree with you, though. Think of it as a quadratic. We did a bunch of stuff on quadratics a few months, wow, a few days ago. And I'm going to say to you that we can factor it. That's going to give you a little bit of a clue. Look at that again. And you tell me what those factors are, because I know you know it. Right? You can factor that denominator like you factor any other quadratic. So what are those factors? Go. Negative 4 and negative 5, you say. Yeah. That's going to give you the positive 20 and the minus 9? Yeah. Oh, nice. You see that? You didn't change your answer. Well done. By the way, I just did something messed up. Let me fix that. It's not x. It's m. Minus 5, m minus 4. Akifa is right. When I take those numbers and multiply, I get positive 20. When I take those two numbers and add them up, I get the minus 9. That's the right combination right there. No magic X required. Okay, so we factored it. Great. But can we reduce it? That's my next task. right? That's my next task, reducing it. So, Ashim, it's your time. Can I reduce this? Is there something that we could cancel out or somehow, you know, reduce it? Can you do that? The negative four, what do you mean? Tell me what you mean. How do you do that? Hmm. Here's how we look for whether it can be reduced. Look for common factors, top and the bottom. Is there a factor on top which is the same factor as the thing on the bottom? You see anything on top and the bottom that's the same? A factor. It's not just negative 5. It's not just negative 5. No, don't say minus. Minus negative 5 means n plus 5. It's just n minus 5. All right? You can say minus negative, it means you're plus. Isn't that true? Okay. So what you're now saying, Ashim, is that that m minus 5 is common to the top and the bottom, right? Okay. So what we're going to do is we're going to go ahead and reduce it down. We're going to cancel it out. So I'm going to say, okay, I thought it was going to, oh, it took it back. All right. So I'm going to say, okay, I'm going to go like this. Right? That's what I'm going to do. And this is like a 1 and a 1 again. That's left over. All right? Okay. Aaron, what do I have left after I reduce it down? 3m over m minus 4, like that? That's what you're saying? I agree. I absolutely agree. The question now for Ashton is, how about restrictions? What causes the problem at the beginning? Not where we are now, but from the beginning. What is it that m cannot be is what I'm really asking. What is it that would cause that denominator to be 0 is what I'm asking you for. Correct, because when you factor it, you notice that those would cause, those two numbers you just gave me, would cause that denominator to become 0. Ashton is right. In the factored form, it makes it more obvious. Not so obvious when you look at the original, but very obvious when you look at the factored form that m, either being 5 or 4, is a real big problem. Right? Because in both cases, it would cause the denominator to become 0. We can't have that. So we have to say, don't use these numbers. These numbers are off the table. We can't use those numbers. Okay, I believe we have just two more. Oh, there are a couple more. Okay. All right. Let's see how well we do with these. Maybe we can fly through these last ones here. The first thing we said, Abdullah, is we need to factor, correct? If we can you factor the top of that? If you can't see it, I can try to make it bigger for you. Can you see it? A little bigger? All right. Okay. Okay. What I'll do is I'll just blow it up this way. That help you out? Okay, go for it. Keep going. Negative 2 and what? Negative 2 and is it positive or negative 3? Positive 3? Okay. All right, let's try that. See how that works out. Let's see if we check both boxes, right? Minus 2 times 3 is minus 6. Okay, that's good. That checks that box. Let's add them together now, see if we get the minus 5. So minus 2 plus 3, is that minus 5? Nah, so that's not going to work. So let's try again. No, no, just leave this to Abdullah. Thank you very much for offering. So I'm going to erase this. I'm going to erase this. Rewind. Try again. Okay, we'll try that. Negative 6 and 1. Minus 6, positive 1. Okay, let's try this now. Multiply those two, we get minus 6. Check that box. Minus 6 plus 1, does that give us minus 5? We'll check that box as well. Good stuff. Thank you very much. All right. Krisha, can you help me out, please? Can the bottom be factored as well? Tell me about that. Difference of squares. You nail that as well. You saw that that was a square, that was a square. So it's just a difference of squares. Yes. All right. I tell you what, can't you wait about 15 minutes when we get to the break there, and then everybody can go at that point, okay? So Krisha says, look, this is a difference of squares, so it's just going to be x plus 6 and x minus 6. Great. Does that help us out? Does that make this thing reducible, is the question? Okay. Athuzan, go ahead. It sure does. Leaving with one and one. So why don't you continue and tell us what's left after you cancel that out? What's the answer going to be after you cancel that out? Correct. But we still have restrictions. We still have restrictions. Wanya, what do you want to tell us? So the restriction is 6. Is there any other restriction? Or is that it? What's that? And minus 6 as well. What I'm going to do is I'm going to put plus and minus 6. Right? Because there are those two restrictions. And that's just a short way of saying plus and minus 6. So plus 6 and minus 6. Well done. Well done, Wanya. Thank you very much for offering. I appreciate that. Get the hang of these things. It's not that difficult. It's not that scary. Right? Some kids, some students get a little bit messed up when they see these, and it really isn't that bad. Okay, let's try this one. Yes.
I don't understand how you get the restrictions.
Okay. I always appreciate that you do that. Ask yourself the question. This is not just for Aria. It's for everybody else who didn't have the courage to do what she just did. Right? You get the restrictions from going back to the original and asking, what could have made that denominator become 0? And I said to you a few minutes ago, set it equal to 0. Take the x squared minus 36, set it equal to 0. What could cause the x to make this, what value of x is going to make this equal to 0? So one way to do this, Aria, is to say, I could just simply put that 36 on the other side. X squared equals 36. And then square root it. Isn't that true? So the square root of the x squared, square root of the x squared, is equal to the square root of 36. And that's, of course, plus and minus 6. That's one way we could have done it. Right? Just simply ask what makes the denominator equal to 0. Yes, Jahim? For C, could we have done what we just did here? Yeah, in a sense, yeah. Well, okay, let me go back. In this case, this denominator here needs to be in factored form. All right, because if I set that equal to 0, if I take the m squared, that's wrong. If I take the m squared minus 9m plus 20 and set it equal to 0, the only way to solve that is to factor it first. Make sense? So in this case, I'd have to factor it, which is what we did on the second step anyway. Good question, by the way, Jahim. Thank you for that question. Okay, so if everybody is now satisfied with how we get those restrictions, let's get to the next one. X minus 5 over 10 minus 2x. Can we factor Masumi is the question, right? Look at the top, look at the bottom. Can I factor the top? And if I can't, can I factor the bottom? Could you possibly, his phone is going off there? Yeah, just put on silent for me, please. I can hear stuff from the next room. My hearing is that good. Good. But you can factor the bottom. By 2? Okay, good. Let's do that. Let's do that. So Masumi says, okay, the top is a write-off. Yes, sir. And put minus 2 plus x plus 10? Yeah, we could. We could. That's a good question, by the way. And there's a good reason why you probably asked that question. So hang on to that for a second. So Masumi says, okay, look, top can be factored. It's just x minus 5. And I agree. The bottom, though, can be factored by factoring out a 2. So Masumi, I'm going to come back to you now. What happens when I factor out that 2? What am I going to get? 5 minus x. So you're thinking, is there a common factor here? Does it look like we have a common factor? Laurie says no. AJ says no. Angela says no. We got 3 no's. Yes. Just turn it around and just say 5 minus x on top. That's a good thought. Let's change things up a little bit. Masumi wasn't wrong when she factored the bottom. But Masumi, what if, instead of us doing this, we tried a little different strategy. Let's see how we do this now. So this is one possibility here. But let's try another possibility over here. What if I let the top as x minus 5? What if I factored out minus 2 instead? Excuse me. What if I factored out minus 2 instead of positive 2? Let's see what the result of that is. Okay? Let's see how that changes things. So I'm going to divide both of these terms by minus 2. Charmaine, I want to hear from you on this one. Let's factor out minus 2. You'll see why I'm doing that in a minute, okay? But instead of dividing by 2, which is legit, completely legit, I'm going to divide by minus 2 this time. All right? So minus 5. Keep going. Plus x. Now you're looking at that and thinking, that still doesn't look like we can do anything with it. Until, yes. Yeah. Until you say, look, this is x minus 5. Can I not make this x minus 5? Instead of saying minus 5 plus x, just change the order. It's still a minus 5. It's still a positive x. Let us put the positive x first and the minus 5 second. I can do that. That's perfectly legitimate. Yes?
How do you know whether to put like the number in front another bracket and then do two numbers in two brackets?
Okay, one more time. How do I know when to? And I really.
So have like a number in front and then only one bracket, or when to have two brackets?
Good question. Okay. If it is. All right, let's answer the question this way. Look at all the terms that you have, every single term, and ask, is there a number that can divide into all of these terms? Let me take you back to, we're just going to do a little detour here because I want to take everybody, respect everybody's question. In this case on top here, when you try to factor it, there is no common factor between all 3 of these. Right? There's nothing that goes into x squared minus 5x and minus. So there's no common factor. If there was, I would have taken that out and put one number in front and then divide everything by it. In this case, there is a common factor on the bottom of 2 or minus 2. We're finding out that using minus 2 actually works better because of this. It makes me have the right signs for the x and the minus, x and the 5. It becomes a positive x and a negative 5, is what we're saying. So, can this be reduced, is the question. Methuselah, are we listening? Yeah. You can get a plan. You can do all the phone stuff in a few minutes, all right? All right, let's just focus here. Back to you. Yes, yes, yes. To take your point, yes. So now let's reduce this because we can. Okay, What do you say? Okay, so when I cancel this time, what do I have left on top again? I've always done that, a 1. Sometimes people forget that 1 and think it's a 0. It's not, it's a 1. It's another 1 down here as well. So, what is the result of all of this? Yes. I'm going to say negative 1 over 2, but it's the same as what you just said. All right, instead of putting negative on the bottom, I put it on the top. You were doing that exercise online a while ago, and the computer was kind of forcing you to use a negative on the top and not on the bottom. I'm doing the same thing here. Okay, yes. Right there. When we reduce it, we always had a 1 left over. It's never, it is, because how many times, because you're saying divide this by x minus 5 and divide this by x minus 5. So divide it by x minus 5 gives you 1, same thing down here. There's always that 1 that's there. And sometimes people miss that 1 and they think it's a 0. Okay? All right. Are you getting distracted by your phone as well when there's time for that? There's no time for this right now. All right? This is what takes you off track and then you forget what to do on the test. You don't want that. You don't want that, right? Okay, fine. So the 1 on top, I'm going to make that a minus 1 because I'm really going to end up with a positive 1 and a negative 2. And it's better to put the negative on top. It's a negative a half. So I'm thinking, whoa, that's just a number. That's just a constant. What does that mean about this expression then? What do you think it means about the original expression? Anybody have any thoughts on what that means? If the final answer doesn't have any more x's in it, okay, all x's are gone. All I have is a number, in this case minus a half. What does that suggest about the expression?
Excuse the interruption. Would all teachers please submit your attendance now? That's all teachers, please submit your attendance.
Pretty sure I did that already. So can anybody tell me what you think that means? Yes. Yeah, you still get into restrictions. Yeah, we're going to get to restrictions in just a minute, so hold that thought. But I'm asking a little different question, and I take that as a valid suggestion. What does it mean that the original expression has no more x's in it? What does it suggest? So every time we did this before, we still had an x in the end. There was always that variable at the end. But every time we do this, we end up with just minus a half. That's my clue to you. Here's what this means. Doesn't matter what x you put into this, answer is always minus a half. That's what it means. Take any value of x you like except 1, which is what you're talking about. Doesn't matter what value of x you choose, 10, 5, 52, a million. Put that value of x into this function, it works out to minus a half. Yes. It does. See, I guess I shouldn't say it that way because there is one restriction still. And that's what you were talking about. The one value of x which is restricted is what you just said, which is 5. So put anything else you like in here. Put anything else you like except the one restriction, and you're going to get minus a half. Sorry. Folks, though, listen, if I kick your thing as I'm passing us, I move. I don't sit down. Okay, you've already seen that. So I need to be able to move around. So this is the actual answer, but x cannot be equal to 5. Are you thinking, but there was no x in the end, but there still was a restriction from the beginning. X cannot be 5, right? 5 would make this thing become, if any one of these becomes 0. This would become 0 if I had a 5 in there, right? So go back to the original and ask the question, which value is the problem? And that's the one that's the problem, okay? Are we clear on that? Yes.
I have a question. Can you go to D for 1 second? I have a question on that.
D? Yep. We can go to D for a second. We can go to D for more than a second.
So when you said x is 1, right? You use that as one term. Is that how you cancel out x's?
You're thinking you could cancel the x's? No. Common mistake that students make, and hopefully we're going to correct that right now. Manhill is asking, and I see this a lot. Look, there's an x here, there's an x here. Why don't we just cancel those guys out? No. It's part of, and you're on the right track, it's part of a sum. This is also part of a sum. You can't take a piece of a sum and cancel it out. You can take a factor. So this times this, you can take that factor and that factor, but not a piece of a sum or piece of a difference either. Yes. So what's that? If it's being multiplied, yes. If it's a factor, then absolutely right. I see that over and over and over, and I hope I don't see it again. Right? I hope that Manhill's question will prevent you from making that mistake. I think we have one more left. Then we get our break. Yeah, last one. Everybody can get to the bathroom, take out your phone, text your friend, see what's going on Snapchat, all of that stuff. But not now. Let's just get this done first. Now, where are you going? Sit down. All right, we have one more left. All right. Excuse me. N squared plus 2n minus 15. The first step we said was to factor. Okay, yes. Oh, yep, we sure can do that. We absolutely can do that. Is that good now? Okay. So I need your help to factor. That's where you come in. So let me talk to Shaluja for a minute here now. Shaluja, can you help me out with factoring the top? And I'll ask somebody else to help me to factor the bottom. Then we're going to talk about restrictions and finish up this, get you to your break. So, what do you say, Shaluja? Can you help me to factor the numerator, please? Go for it. Okay, let me give you a little bit of a hint. And please try to remember, if anything that we're doing doesn't make sense, you need to stop us. Don't just sit there. Right? We have great examples of students who do that all the time. Right? If you're not sure about what we're doing, you got to stop us. I'm asking you to factor. So I'm asking for two numbers that multiply to give you minus 15. I added to give you 2. Make sense? That's your job. Go. I'm going to put n and n here. That's an m, Mr. Kamok. You got to write properly. Let's try that again. Okay, go. Factor. I'll write that down, and then we'll test it out. Or is it supposed to be n's? No, you're really embarrassing me. I mean, that's my best n, and you're making it sound like it looks like an m. All right, I'll try to fix that. I'll fix that in a second. All right, in fact, let me just fix it now. That was bad. That was terrible. All right, let's try this again. So, n, and is that better? Okay. All right. I know, it does. It does, yeah. I need to go to writing school. I desperately need. My mother tried with me. Trust me. That's the best I can do, folks. That's it. All right. So you said, sorry, you said what were the two numbers again? Okay, let's try that. Plus 5 and minus 3. Okay, let's test this out. 5 times minus 3, does that give us minus 15? Check that box. 5 plus minus 3, does that give us positive 2? Check that box. We're good. Get the thumbs up in the back there from Masumi. Okay, good. All right. So, AJ, can you factor the bottom for us now, please? I have to write another n again. All right. Good. Go ahead. Plus 3, you said? And what's the other one? Minus 4. So n minus 3. Okay. Let me change this. You're saying minus 3. And what are you saying for the other one? Can't hear you. Don't listen to him. But next, what's the other one? Negative what? Minus 1. Don't listen to him. No, like he knows what he's talking about. Listen to yourself, okay? So minus 1. All right, let's test this out now. Minus 3 times minus 1. AJ, does that give us positive 3? Sorry, I can't hear you. Okay. Minus 1, sorry, minus 3, minus 1. Does that give us minus 4? Okay. I can't hear him. I mean, this is a muffled thing. So try me one more time. One more time for me, please. Does anybody have an AJ to English dictionary? Because I don't know what that is. Okay, all right. Thank you very much. All right, here we go. Can we reduce this one down? Go ahead, Shrish. Shriyash. Good, good. So we'll do that. And again, we're going to put a 1 in its place. We're not just going to cross it out. There's a 1 here, there's a 1 there. All right? What is the result? Ashton, your time. Can you finish this up for us now, please? Good stuff, good stuff. But the more interesting question for Sarah is, what are those restrictions? Can you help me with the restrictions? Always refer to the original or the factored from the original to help you to answer that question. What values of n are a problem? What is it that we're saying n cannot? My n's are looking better, right? Isn't that true? Isn't that last n like a good one? Okay, good. What values of n? Say again?
3.
So just 3? Or is there any other value? So n cannot be equal to 3. Anything else? So that's it? No. And by the way, I forgot to tell you, you got to keep those headphones out while I'm teaching, please. Keep the headphones out while I'm teaching. All right. So you want to say what? 3 and 1. That's what you're going to tell me? Good. Both of you. Che and Atifa both agree on 3 and 1. So 3, yeah, we agree with that. Sarah, but also 1. Because you look at the denominator that was factored, those are the two numbers that cause the problem. All right. We can review what's there, what's written there. We can review it later on. To be honest with you, keep coming back to this stuff, and you can always look at it in the video. I think that what we're about to do will make all of this obvious, and some of it is really just remembering the stuff you did when you were warming up this morning. Review of rational numbers. Talked about that this morning. One of the things you might want to start doing, I did say that when you're multiplying, multiply the two tops, multiply the two bottoms. But what I didn't say is that if you can reduce anything, you should, to make your life easier. So, for instance, what do I mean by that? Since I'm multiplying, I'm actually going to grab my stylus here. I'm actually going to say, you know what? There's a number on top and a number on the bottom that I can divide by 3. Even though it's on top of a different number, as long as one is on top and one is on the bottom, I can reduce that down. So I'm going to divide this 9 by 3, which gives me 3, and divide the 21 by 3, which gives me 7. I'm going to divide this 5 by 5, which gives me 1, and this 10 by 5, which gives me 2. So what I'm doing is I'm actually making it easier for myself by reducing it at the very beginning. Divide through by 3, the two numbers that are visible by 3, 3 and 7. Divide through by 5, which gives me 1 and 2. So what's left is 3 times 2, which is 6, over 7. No. Yes, Shami. What about the denominator? It's a 6 over 7. Oh, it was 21. It was 10 over 21. Okay, it was 10 over 21. So I reduced that with the 9. The 21 and the 9 I could reduce down. Now, we could have said, why don't I just multiply the two tops? Well, okay, if I did that, what I would have got is I'd have got 90 over whatever 5 times 21 is, 105. Did that in my head, so you might want to double check. I think that's 105. But this still reduces down. Right? This 90 over 105 still reduces down to 6 over 7. So I'm saying don't bother with, going the long way. Just simply reduce at the beginning, makes it easier at the end. Okay? Second one, we talked about this morning. I'm going to keep the 12 over 7, but I'm going to multiply by 14 over 18. I said that when you are dividing, it's the same as multiplying by the reciprocal. So we're going to do that. Then next, I'm going to reduce. We use the red to reduce. 7 goes into 7 once. 7 goes into 14 twice. 6 goes into 12 twice. 6 goes into 18 3 times. So what is left at the end is 2 times 2, which is 4, over 3 times 1, which is 3. Yes. Because 6 is a common factor of 12 and 18. Right? Look for what's called the highest common factor between the numbers and factor it down. So 6 goes into 12, 6 goes into 18. Thanks for the question, by the way, Atifa. Really admire that there are people who will step up and say, I need you to just go by that or to explain that. Okay. Now, let's start you off really slowly here with the expressions. So the first one doesn't need me to explain anything. I'm going to go ahead and I'm going to say what we just did a few minutes ago. I'm going to reduce this down. 3 goes into 3 once. 3 goes into 6 twice. Nothing else can be reduced. So it's 1 times 1 over 2 times 2, 1 over 4. Sure. 1 times 1 over 2 times 2. So this 3 goes into 3 once. 3 goes into 6 twice. And that's why that becomes 2. So it's 2 times 2, which gives me the 4. 1 times 1, which gives me the 1. Could I have just multiplied it out? Yeah. I'd have got 3 over 12, which is still 1 over 4. Okay? But I think reducing it makes your life easier. And that's why I reduce it first. Are there any restrictions? No. Okay. Yes, Jay. I think it's better to, yes, simplify it after you flip it. Yeah, absolutely. Yes, AJ. That's 1 over 4. Yes. Oh, before it was 1 over 6. And times 3 over 2. So I was asking about restrictions. Is there any restriction? Well, there was no x at all in the original. There is no variable there. There's nothing that can make this become 0. So there are no restrictions. It's when you have a variable in the original denominator that you can have restrictions. Okay. How about this one? Now, just to make it look like a fraction, I'm going to put this over 1. I have an x squared on the top over 1. I have a y over an x. Any suggestions as to how we can tackle this one? I'll take a suggestion. I won't call on anybody in particular. Was that volunteering? No? Okay, yes. Anyway. It is, yeah, you're right to ask. It's actually squared. Let's see. View, zoom, 200%. That better? Okay. So any suggestions? Yes, Nikki. Oh, help yourself. Help yourself. Suggestions? Yeah, because that x squared and that x, again, they have the same base, so I can subtract the exponents. Remember that? All right, you're dividing, so you can subtract the exponents. So that's equal to x to the power of what? What x am I going to put that to? What power of what? Well, it's 2 and 1. To 1. Which I don't really need to write, because x to the power of 1 is x. Then I still have that y. It's just x dot y. That's what's left. I can't reduce that anymore. So it's just x times y. The question now, yes. Pardon me? Dot means multiply, right? So instead of writing the times, I just put a dot. It means to multiply. Or just xy. To be honest, I could just put xy. All right? Yes. So you could have suggested, yeah. So, yes. Can I go what, sorry? Over this one? Okay. So thank you for the question. Jaheen. I have an x squared on top, I have an x on the bottom. So I'm dividing, right? Anything on top is being divided by anything on the bottom. So they have the same base of x. So it means that I can subtract the exponents. The exponent on top is a 2. The exponent on the bottom is implied to be a 1. It's not there, but it's implied to be a 1. So it's just 2 minus 1, which is 1. And x to the power of 1 is what I have there. I just don't put the 1. But that's just implied. Okay? Thanks. Okay. Let's see what we do with this. X squared over 6 times 3y over 2. 2x, sorry, over 2x. My suggestion is reduce the numbers first. Whatever numbers you can reduce those first. Okay? So Suchir says what? Say it again? Yep. Yeah, we're going to deal with the numbers first. So 3 goes into 3 once, 3 goes into 6 twice. So that's the first thing I would do. What else? Yes, AJ. I'm going to put a speaker in front of you. Put a microphone in front of you and put a little speaker in the front. Talk to me. Yeah? Yeah, gives you what? Just simply x. Okay. Essentially, what's happening is this. This x is canceling out one of these x's on top, leaving us with just simply x. That's really what's happening. Right? Because this x is to the power of 1. That's x to the power of 2. So that leaves me just x to the power of 1 on top. We can't reduce anything else. So what is left on top and what is left on the bottom is where we have to go next. So, Gary, what do you think? What's on top? Just simply x. What's on the bottom? No. Yes. 4. 2 times 2. Remember, there's 2 here and there's another 2 here as well. Where's the y? That's a very good question. That's such a good question that it means that I messed up. I left the y out. Where did the y go? The y should be there. Y has a right to be there. So it's xy over 4, absolutely. Okay, excuse me. Let's talk restrictions now. It's your turn. So I'm coming to the front of the room, and I'm going to ask Manahil to help me with restrictions. Any restrictions, Manahil? You have to look at the original. What can't be 0? There are no x's in the denominator, though. No, in the numerator, they're sorry. Focus on the denominator is what I'm trying to say. So there's only, oh, there was an x there. You're right. Oh, thank you. You're absolutely correct. You're absolutely correct. So x cannot be 0. Yes. Yes, I'm being corrected, and I'm humbly going to acknowledge that you're right, I'm wrong. So it's an x that cannot be 0. Okay. I hope we can get through most of this stuff today. It's quite a bit, but we can do a lot of it. Okay, let's get to the next one. 2 over minus 3 divided by 8 over 15. So we already know how to do this, right? This is a division. So what we're going to do is we're going to put the 2 over the minus 3, leave that as it is. We're going to multiply that by 15 over 8. Change a division to a multiplication. All right. Can we reduce it down? Yes, we can. Can somebody tell me how we can reduce this down? Wanya, go ahead. Okay, so I can divide minus 3 by 3, which gives us what? Actually, minus 1. And we can divide this by 3, which gives us what? 5. Good. Anything else? Thank you, Wanya. Anything else that you notice that we can reduce down? Atifa, go ahead. Okay, so 2 goes into 2 gives us, and into 8 gives us, good. So what are we left with here then? What is left? Yes, go ahead. 5 over negative 4. And I prefer if you put the negative 5 over the 4. Is it wrong? No. You can put a negative on either one. Or an alternative, just put a negative in the front. Over the, in front of the whole fraction. So either put it on top or the bottom. Can I put it on both? The top and the bottom? Is that okay? Why not? That sounds like such a good idea, right? Yes. Gives me a positive. I'm going to change the fraction to a positive by doing that. So I can put the negative on the top, on the bottom, or in the front, but not on both. That would change things. All right, okay. How about this one? So it's x divided by x, sorry, x squared divided by x cubed. Think about, yeah, let's not get that phone to get in the way now. We don't want that. We don't want that. Oh, restrictions, sorry, restrictions. Restrictions. Any restrictions here, folks? Any restrictions here? All right, I see that Sarah doesn't think there are restrictions. What do the rest of you think? Shay says no. Nobody sees a restriction here. Let's move on. There's no restriction. This is all numbers. All right, there's no x here. So there's no restriction. Let's write that though. No restriction. Okay, let's get to this. X squared divided by x cubed. X squared divided by x cubed. So I'm going to do what we've always done. Sorry, you had so what do you want to tell us? Yeah, go ahead. We could just simply subtract, to be honest with you. But the other thing I was going to say is we could still treat this as being x squared multiplied by 1 over x cubed. Okay, we could still do that. But the truth is that it's easier to just do what you just said, right? Which is just to subtract the two exponents from each other. So what does that give us when we subtract these exponents? Yes. Negative x? No, negative x is a different thing. But I know what you mean. I know what you're trying to say. Angeli, what do you think? That's what you're trying to say, x to the power of minus 1. And I would accept the answer. Another way of writing this, by the way, is this way. 1 over x to the power of positive 1. But are there restrictions, is what we want to ask. What say you to that? Are there any restrictions on this? Are there any restrictions from this expression? That's what I need to find out, Jasmita. Any restrictions? What can't be 0? X can't be 0. There you go. Done. Done. We have a lot to get through. So stop me if we're going too fast, but I'm trying to move this along here. This one. Well, I'm going to do exactly what I just did. I'm going to say 2x squared over minus 3 times what? Yes. The 15 over the 8x cubed. All right. Can this be simplified? Hashim, it's your time. Jump in. Help me to simplify this. Look for things that I can simplify. What other common factor do they both have? I want to know what to divide both numbers by. By 3. Okay, let's do that. All right, so we're dividing this by 3, and we're getting minus 1. We agree on that, right, Hashim? Yeah. Divide this by 3 now. Tell me what you get to divide this by 3. If I see you touch that calculator, me and you, okay? Divide that 15 by 3. No, you're dividing 15 by 3. No, try again. By 5, okay. Okay, what else can we reduce? All right, that's my next question. Go ahead, please. Go ahead, Abel. 2 goes into 2, and leaving with what? And 2 goes into the 8 as well, right? Nice. See, I didn't see you even touching your calculator. This is what we need to do. Okay, so that's good. So we're left with the numbers, but now we have the exponents. Yes. Can I take it away? Just throw it out and just say we don't want you here. Yeah, you could actually. You could. But we're gonna do it by just the numbers, though. I know what you mean. Okay, but now we have. Okay, in terms of their, let me tell you how I think I want to do this. I know you can say x to the power 2 divided by x to the power 3 means you subtract the exponents and then you end up with x to the power of what? Minus 1, right? Yes? Everybody with minus 1? But here's what I'm gonna suggest we do. Divide this by x squared, which leaves you with 1. Divide this by x squared, which leaves you with x. I prefer if you did it that way. Sure. Divide the top and the bottom by x squared. So x squared into x squared gives you 1. X cubed divided by x squared gives you just simply x. So it stays as a fraction at the end, is what I'm saying. Leave it as a fraction. Leave it as, if you put x to the minus 1, it's no longer a fraction. So, what's left over now? That's really what we have to figure out. Yes, Che, go. Negative 5 over, sorry? Negative 1 over 1. Okay, yeah. But give me what you multiply it all out. No, that's what I'm asking you to do. Over 4x, that's correct. Remember, there's a negative on the bottom, but I'm going to put the negative on top instead. That's what I'm doing. But there's 1 times 1 times 5. There's minus 1 times 4 times x. That's minus 4x. We'll just put the negative on the top. I just think it's neater. Yeah.
So you know how two x squared? Doesn't the x to this x squared turn into a one too?
Yeah, it does, but it really comes into a negative 1. And because the x is on the bottom, it's like saying x to the minus 1. Okay? Yes. Yeah, you could do that, but then you couldn't put the negative on the top as well. Can't put it on both. Because I chose to put the negative on the top, I didn't want to put it on the bottom. Okay? Yes, AJ. What happened to the 1? The 3, well, that got cancelled with the 5, remember? The 3, you divided the minus 3, that's what Hashib did. Divided the minus 3 by 3, which gives us 1, or negative 1. Yes. We could have done that. We could have said the same base of x, so that's minus the exponents, which gives, in this case, will give us x to the minus 1. But in a sense, that's what we have because the x is on the bottom. So it's really like saying x to the minus 1. Okay? I think you're not convinced. I think you're asking why we don't have the x's being subtracted because you're dividing. Is that what you're asking? What's that? It is x to the minus 1. This is, in a sense, yeah. In essence, this is x to the minus 1. Anytime you have an x on a denominator, which is where it is right now, it can be put, this, I could have written this as the following. Minus 5 over 4 times x to the minus 1. Those two things are the same. Okay? The x on the bottom, it suggests that it's an x to the minus 1. Okay? So that's why that is. Both of these are equivalent. Okay, restrictions. X cannot be equal to what is the question? Yes. X cannot be equal to 0. Because when we flipped it over, this x was on the bottom, we have to say that x cannot be equal to 0. All right. Now, let's get to this. Binomial factors. First one is the easiest one because it's already been factored for you. So even though when we did this first, everything was numerator, denominator, now we're trying to multiply two things. But the good thing is that we now have a common factor in the numerator and the denominator. What is that common factor? Can anybody see what that common factor is between numerator and denominator? Yes, Aaron. So what's that? Let's speak up for me, please. The B. Um, no, because there really is no common factor of a B, right? There really isn't. B is part. The B. If you're talking about this B right here, that's part of a sum. That B is part of a difference. So I can't consider that to be a common factor. All right. But let's hear what Sahil thinks. The B minus 3 is a common factor because all of this is being multiplied by 2, all is being multiplied by 5. So that is a common factor. So I can see if I can do this now. I can, I want to get a, all right, I'm going to undo that. Oh, I know how to keep that on. I just remember how to keep that on now. So if I take this up, then I pull this out, I think it will stay. No, it doesn't stay. All right, that didn't work. All right. Anyway, so I'm going to put a dotted line in this time. So you can kind of see what's going on behind it. See that B minus 3 there? That is a common factor. Right? That is a common factor. What other common factor do you see, though? Apart from the B minus 3, what other common factor? Put the phone down, brethren. Put the phone down, not no. All right? It's a Jamaican thing. Don't worry yourself. All right? Yes. The AB here, this A and this A, we can reduce those down as well. All right? Those can be reduced down because it's part of a factor. It's not A plus B, it's A times B. So that's part of the common factor as well. So how do we reduce that down? Divide this by A. This leaves me with 1. Divide that by A. That leaves me just simply A. This used to be A squared. It's now just simply A. Because we're dividing the A squared by A. Can we reduce anything else? Is anything else reducible? Apart from the A's and apart from the B minus 3, there are other things that we can reduce. Does anybody see them? Okay, let me hear from yes, Akifa. So the 10 and the 5. So 5 goes into 5 once, and 5 goes into 10 twice. I believe that's what AJ was going to tell me as well. Anything else can be reduced at this point. Do you see anything else that is reducible? Anything else? Yes, AJ. Say that again. The B, no, because this is part of a sum. I can't just take a piece of a sum. That's what we were saying before. You cannot do that. If it was just B on its own, then yes, but it's part of a sum. I can't take a piece of a sum. I can't do that. Okay, yes. No, you can't simplify anything else on this. All you can do is multiply it out at this point. So on top, we'd have 2 times A times B plus 3. And on the bottom, we have 1 times B. That cannot be simplified anymore. Right? I have 2 times A. The B plus 3 is still there. Oh, hold on, that's wrong. There was another 2 here. That's wrong. Sorry. I didn't see that 2. So this is actually 4. Yeah. That's actually 4A. So that 2 times that A times that 2 gives me 4A times the B plus 3. That 1 times the B just gives me B. Okay. Now it comes the really one of the most challenging restrictions we've talked about. I need all the restrictions now. Can anybody step up and sort of be brave and say, I think I got this. I think I know what those restrictions are. Okay, let me give Suchir a chance on that one. And then we'll see if Suchir somehow doesn't quite get there. Then we'll see if between both of you we can get it. Okay, Suchir, go. Okay, I need to know what variable we're talking about. So this cannot be equal to this. B cannot be 3. Good. Is there any other value of B that would be a problem? 0. Thank you very much. But we're not done. We are not done. There is more. Anybody? Yes, go ahead. There you go. A cannot be equal to 0. Because that would also cause a problem. So A cannot be 0, but B cannot be 3 and B cannot be 0. Sorry, go ahead. It is AB, yes. It was AB, yes, before. Yeah, yeah, absolutely. Okay, folks. Okay. I mean, stop me. I'm okay with stopping. I'm okay with doing the rewind. I'm okay with that. All right. Okay. Let's go down. Okay. Not getting any easier, folks. The good thing is that these are factored already. That's what's good. It's all been factored out for you already. Just a matter of identifying the common factors and reducing it. Okay. Now, it's a division though. Remind me how we do a division again? What do we do? Yes, Atusha. You flip this the second one, right? Okay, we'll do that. So, I'm going to write this as 4x minus 2y over x squared y. Nothing changes there. Changes to a times xy squared x plus y over 8 2y minus x. Okay, this one looks a little challenging though. I'm looking around and trying to find my like terms. Yeah, this one is going to take some thought here, folks. We're going to need to slow things down and look at this one very carefully. All right. Where do we start? What's a good place for us to start? Rosie, are we good so far, Rosie? Following along? Everything making sense to you? How about you, Abdullah? All right, good. All right. Jasmitha, are we good so far? All right. Look for things that can be reduced. All right, look for things that can be reduced. Wanya, what do you want to tell us? The 4 and the 8, that's a good place to start. Deal with the numbers first. Is that what you're going to tell me, 4 and 8? Or you had something else? Okay, let me get the 4 and the 8 out of the way. 4 goes into 4 once, right? And 4 goes into 8 twice. Good. What else do you see there? Yes. The x and the x squared. So I can divide this by x and divide that by x as well, right? Okay, good. So if I divide this by x, I'm going to get 1, right? If I divide this by x, I'm going to get x squared by x. I'm going to get... No, the top one is 1. But what about the second one? Just x. Okay, good. All right. Che. That's true. So I can divide y by y to get 1, right? And I can divide y squared by y to give me y. Good. I like where this is going. Anybody see anything else? Yes. Excuse me. Look at you. I love that. That's so perceptive of you. Now, this is what was the biggest challenge for this one. And Angela nailed it. She said, look, x minus 2y and 2y minus x, they're not the same, but they're kind of the same. It's just that you reverse the order when you subtracted them. Is there any way to fix that so that they're the same? Well, if I divided either one of these by minus 1, it would make the order change. So here's what we're saying. I'm going to rewrite this now down here. Instead of saying positive 1, I'm going to say negative 1. Then I'm going to call this 2y minus x, right? Changing that from a positive to a negative will reverse the order of these two here. On the bottom of this, I'm going to put the x times the 1, which is just simply x, multiplied by the 1 times the y, which is still y, x plus y, over the 2 times the 2y minus x. So what we've done is we've rewritten it and taken out all the stuff that we already reduced out. Right? We already reduced out the x and the x squared and all that stuff, but we still had an x there. We had a 2 here. So we're still left with 1 over x minus 2y, except because it's a negative 1, it's now 2y minus x. That's over x. 1 times y, which is just y. X plus y over 2 times 2y minus x. So why did Angela do that? She noticed that no, these two guys are the same factor. You want to say what, Jay? Yeah. Yeah. Yeah, it's basically the same thing, basically the same principle. Yes, you're quite right about that. So, can we reduce this some more now that we've done that? Yes, we can, because I'm going to go ahead now and say this guy and this guy reduces to 1 and 1. So now, since I don't see anything else left, I'm now ready to write my final answer. My final answer looks like I'm going to take minus 1 times 1 times y. So that's minus y times the x plus y all over x times 2, which is 2x. And guess what? That's it. That's all that's left on the bottom. Just the 2x. But restrictions. That just makes this a lot more challenging. Restrictions. Let's go back and look at the original and see if we can come up with those restrictions. I'll take volunteers on this one. Can anybody tell me what restrictions you notice or think are there on this one? Okay. Excuse me. Aria, what do you think? Any other restrictions? Y can't be equal to 2. I think 2 would be fine if we put y as 2. I don't think that would be an issue at all. Looking at it right now, I don't think that's going to be a problem for making y 2. Anything else you want to try out? Okay, let me hear from Manhale. I see your hand as well back there, AJ. Go. Absolutely. This x squared y here tells me that x and y cannot be 0. X and y cannot be equal to 0. Absolutely correct. AJ, was that the one you're going to tell me you have another one? And I have good hearing, folks, and I still can't hear you. Try again. X couldn't be 2. That's what Aria was saying, but I don't see any issue with x being 2 though. Putting x as 2, it doesn't really cause. If there was an x minus 2 somewhere, I would say yes, but I don't see that anywhere unless I'm missing it. So no, I don't see a 2 being a problem. Sorry. Can anybody come up with anything else? This was a little technical, a little bit more involved. Okay, Nakeem. Okay, he's right. X plus y cannot be equal to 0, or another way of saying it is that x cannot be equal to minus y. These are both equivalent statements, right? I don't need to put both of them because really both are saying the same thing. I just rearranged it. X cannot be equal to minus y, or y cannot be equal to minus x. Okay, that's the same thing. So these are both basically the same. There is one more. There is one more restriction. Yes, there is another one. Okay, you put your hand up and put it back down. That's all right. That's okay. Any other restriction anybody can see? Any other restriction anybody can see? Okay, you're going to stick with it this time? Go, Sahil. There you go. There you go. The other restriction is that x cannot be equal to 2y. That comes from this right here. 2y minus x equals 0. So it means that 2y cannot be equal to x. X cannot be equal to 2y. Same thing. So these are all the restrictions. Let me underline them. So there is, or circle them, I guess I should say. There's this, and either one of these. I'm not going to circle both. Let's go with this. So those are the restrictions. X comma y not equal to 0. X not equal to 2y. X is not equal to minus y. Yes. Okay, sign up for me, please. Okay, yes.
I think it's the restriction for x plus y equals 0.
X plus y equals 0, because if you looked at the, thanks to that question, look at the original denominator right here. There was an x plus y right there. Okay. Okay, yes. No, you have to get them all. You have to get them all. Yeah. So hopefully on a test I won't make them too much. This one has a lot. This one has 1, 2, 3, 4 restrictions. Guess you don't know yet until you see it. I'll try. I try to make I don't want to make a test something that is too tedious though. So I'll probably try to make it maybe only 1 or 2 restrictions. Okay. Yes, Shreyash. Okay. Because if you go to the original expression, there's an x plus y in the denominator here. So you're saying that these two together, if you add them up, should not be equal to 0. Because if that is 0, then this whole denominator becomes 0. Make sense? Okay. We'll see how much of this we can get through here. The top of this is just steps to take, but I'm going to go through the steps anyway. Not surprisingly, sometimes you have to factor for yourself. Sometimes you have to factor for yourself. So this one isn't factored. This one doesn't come with the factors already written out for you. You have to factor it yourself before you try to multiply them. By the way, I did put the homework into the calendar, but I'm going to have to adjust it because I'm not sure we're going to get through as much as I plan to get through. And I want to give you some time to get started on the homework. So don't start the homework until I make some changes, okay? I think I'm going to have to split this over 2 days. All right. Where do I start? Yes. Yep. Let's do all the factors we can. Let's factor all until we can factor no more. We're going to factor ourselves into a frenzy here, right? We don't stop until we think we've factored everything. So, can the y plus 2 be factored? Can this be factored? The y plus 2, can I factor that? No, I'll just put that back. I'm not sure why I'm using red. Whoa, that's not what I wanted to do. I wanted to do this. Come on. Okay, so the y plus 2 cannot be factored. What about that denominator? Can that be factored? The 2y minus 2. Can I factor that? Is there any common factor there? Go check. Factor out the 2. And what am I left with when I factor out that 2? One, you go. Good. Times. Can I factor the numerator for the second one? Emily, what do you think? What's the common factor there? Good. So when I factor out that 10, what am I left with? Go, Emily. Go ahead. You can tell me. All right. Jahim, can I factor the denominator? What's the common factor? Okay, and what am I left with? Can't hear you. Y plus what? Y plus 2. Good. All right, so thank you very much, all the people who did the factoring. Aaron, can you tell us what happens next? Oh, the 2y minus 1s. Okay, again, it's a factor, so it's okay to cancel that out. So that leaves us with a 1, and that leaves us with a 1. Yes? All right, thank you very much. Gary, what else do you see? The 2 and the 10. Okay, so 2 goes into 2 once, and 2 goes into 10 5 times. Okay. And Athusan, what do you see? Oh, y plus 2 once, and this also would leave us with a 1. Anything else that you see there? Yes. The 5 and the 5, I agree. 5 goes into 5 once, and 5 goes into 5 once. Uh-oh. What the heck is this thing going to end up being? It's 1 over 1. Or just simply 1. It's 1 times 1 times 1 over 1 times 1 times 1 times 1. It's just 1. Again, what does that suggest about the original expression? I mentioned this before. What is it telling you if the result is 1? Yes, Manya? There are restrictions, actually. There are restrictions. But there's something else I was hoping you'd say it would tell you. Yes. Sub any values of x and y in, those x and y, right? Or just y, it's just y. Plug any value of y you want in. It's going to give you 1, except, no, 0 wouldn't be a problem. Y cannot be equal to some particular value. So this is the answer, but y cannot be, yes, y cannot be 1. And also, and minus 2. There you go. Those are the two values. Yes, I sure can. Yes. Can you see that? So there are two values of y that are a problem. Oh, that's interesting. We're saying the answer is that this comes down to being 1. Then we're saying that y cannot be equal to 1. So you know what this means? I just noticed that, actually. I just noticed that. We're saying that this whole thing comes out to be 1. But then we're saying that y cannot be equal to 1, and y cannot be equal to minus 2. And why, by the way, y cannot be equal to 1 because of the y minus 1 here. And what this means is that there's no solution for this, right? You can put in any value of y. You're always going to end up with that it can't be solved. It's basically what we're saying. There's no solution here. You can try any number you like, you're going to get that same issue. Excuse me. I just noticed that for the first time. Let's see how many of these we can get done. 2, 3. Yeah, I'm going to stop after the next 2. And then I'm going to adjust your homework. So there's this one, and then the next one I'm going to stop. Give you some time to at least get started. We're going to do exactly what we just did. Right? Ashton, I'm going to need your help. Before we do anything else, though, let's deal with the fact that we're dividing. So, and then we change our multiplication, right? Okay. So it's x squared. Let me go back to black. So it's x squared plus 7x plus 10 over x squared plus x minus 6 multiplied by x plus 3 over x plus 5. Agreed? That's what you said, right? Okay. What happens next? Can you give me an idea of what I'm going to do next? I'm just going to ask Ashton that question, though. So thanks for offering. What happens next? Okay, factor the first one for me. Factor the numerator of the first part. I'm going to start by putting these brackets in for you. And then Wanya was volunteering, so we're going to go to her next. So factor the top for us, please. X plus 5 and what? X plus 5, X plus 2. Okay, good. Wanya, you're going to tell us about factoring the bottom. How does that look? X is not a common factor, though. X is only a common factor of the first two. It's not a common factor of the last one. So I set up those two brackets for you to start you off. Factor the x squared plus x minus 6. That's what we're trying to factor here. Try to come up with the two numbers. Thanks, Masumi, and thanks, AJ. One has this. She got this. Go ahead, Wanya. I have total confidence in you on this one. Give me those two factors. It's okay. Wanya's got this. And so you're saying plus 1 and plus 6? Okay. Let me hear the numbers again. X plus 1 and x minus 6? Okay. Let's test it out. Multiply those two, and does that give us minus 6? Let's check that box. That's good. When we add those two numbers together, do I get positive 1, though? I'm going to have to give a thumbs down on that. So it's not 1 and minus 6. So let's erase that for now. Okay, let's erase that for now. And let's try again. And I know you got this, so I'm not going to let anybody else take this away from you. Looking for the two numbers that will multiply to give us the minus 6. And those same two numbers will add up to give us 1. Okay, let's give her a chance. Let's give her a chance. Come on. Looking for two numbers that multiply to give us minus 6, but add up to give us the positive 1 in the middle. Think of all the factors, thanks. Think of all the factors of 6. Think of all the numbers that multiply together to give you 6, and see if you can find a combination that does what I'm asking you to do. Go ahead. Minus 3, let's try that. Minus 3 and positive 2. Okay. Multiply those two together, I get minus 6. Check that box. Minus 3 plus 2, is that going to give me a positive 1? No. So can we fix this? Can we fix this? Go ahead. Minus 2 and 3. So positive 3 and negative 2. I'll try that. See how that works out. Let's see how that works out. So, multiply those two. I'm going to get minus 6. Let's check that box. Plus 3 and minus 2. Does that give us a plus 1? Let's check that box as well. Well done. That's being multiplied by x plus 3 and x plus 5. Okay, that's still there. Sarah, take us to the next step. What happens next? Do you see anything we can reduce out here? Good. So Sarah says we can take the x plus 3's. That gives us a 1 here and a 1 here. Don't forget those ones. What else do you see, Aaron? Yep. Another 1 here, another 1 there. Anything else? Yes. No, they cannot, because they're not the same. Okay? So it means that we're stuck with what we got. 1 times x plus 2 times 1, which means we just have x plus 2 on top. And on the bottom, we just have x minus 2. But of course, the question is still, can there be, or are there, and that's done in terms of reducing and simplifying it, are there any restrictions? I'm going to go to Krisha on that one. Tell me about restrictions that you think are there. What values of x are going to be a problem? X cannot be equal to what? I agree. 2 is one of the values. Anything else? Negative 3 is also true. Anything else? Negative 5. Anything else? I should keep going until people say there's nothing else. Is there anything else? Yes, AJ. He's doing a head scratch there. I'm not sure what that means. You going to get another answer? No? Negative. Did anybody hear that? What did he say? Negative 2? Negative 2? Let's see if negative 2 is really a restriction. We're looking for an x plus 2 somewhere. There's an x plus 2 here, but that's in the numerator. So that doesn't really cause a problem. It's when it's in the I would agree with you if it was in the denominator, but it's not a denominator anywhere. So I'm going to say it's good. We don't need to worry about that. Okay? Yes. 1. 1, 1, 1. Above. In the middle here? That's a 2. No, he's just trying to make me look bad. That's all that is. That's all that is. Right? Yeah, yeah. All right. All right. Be mean to the teacher. That's all right. That's all right. Don't worry about that. I'm all right. We're gonna fix that. We're gonna fix that. We're gonna fix that. X minus 2. Does that look more like a 2 now, sir? All right. Okay. Okay. Mr. Kalmak is learning to write. Okay. Anyway, so this question is done. I'm going to do one where I'm going to give you your homework. And I think we should be able to handle this last one here. And then we're done. Yeah, I promise you, we're done after this one. You have a couple of minutes to kind of breathe and then start the homework. Okay? Let me take a volunteer. I'll make this bigger. I know that looks a little small. First things first. Where do we start? Yes, Jay. Good. Same thing I asked the last time when Ashton did that. So 2 minus 3m, that stays where it is. M squared minus 2m plus 1, that stays where it is. But then we're going to multiply now by 3m squared minus 3m over 9m squared minus 4. That's what we're doing. So I'll take another volunteer. I'll tell you what the next step needs to be, and then let's hear how you're going to deal with it. Aaron, go ahead. Sorry, say it again. The first denominator. So this one here, you're going to factor that? Okay, how can you factor that? M minus 1 squared? You're right. It's m minus 1 times m minus 1. He's quite right. So 2 minus 3m on top. I'm going to write as m minus 1 though, because maybe it's a little easier for us to see what to do with it next. So he's right. It's m minus 1 squared. But I'm going to write as m minus 1 times m minus 1. So times anything else we can factor. Come on, help me out here, folks. I want to wrap this up. Okay? Excuse me. Yes, the chair. We can take out 3m, absolutely. By the way, that dot again means multiplication. Factor out that 3, and what are we left with? M minus 1. Good stuff. Good stuff. How about the other denominator? Go ahead, please. It's a difference of squares. Thank you, Manahil. So 3m plus 2 and 3m minus 2. So we're about to start reducing the heck out of this thing now, right? Abdullah, can you help me out with that? Help me to reduce this. Look at it. Look to see if there's anything that we can reduce out of this. Go. We can take an m minus 1 here and an m minus 1 in the denominator, correct? Okay. 1 and 1. Anything else that you see there? Yes, Sarah. Sorry, say it again. Oh, so if we factored out a minus 1, we could make this into 3 and minus 2, couldn't we? Ah, we like that. That's a good idea. So let's go on the next line and do that. So here's what Sarah is saying. Factor out a minus 1 out of this. So it ends up being 3m minus 2 rather than 2 minus 3m. Let's put what we have left on the bottom. We have an m minus 1 here times 1, which is just going to be that. Then that's times 3m on top times 1, which is just going to be that. On the bottom, we have 3m plus 2 times 3m minus 2. Okay. Help me out, folks. Yes, go. The 3m minus 2, right? Okay. So I'm going to do this. A 1 here and a 1 here. But there's a minus in front here, though, folks. Be aware of that. There's a minus in the front. Anything else that we can factor out? Anything else? Anything else? Anything else? Yes. The m, you mean this m and that m? No. It's part of a difference. You can't take a piece of a difference. That's something I'm hoping nobody's going to do. You can't take a part of a sum. You can't take a part of a difference. So let's see what's left over. We have essentially a minus 1 times 3m on top. Really just simply minus 3m. And on the bottom, we have m minus 1 times 3m plus 2 times 1 again. So that's not going to change anything. And perhaps it would be better for us to write this as, instead of minus 1 times 3, just put it minus 3m over m minus 1, 3m plus 1, 3m plus 2, sorry. Can't read my own writing. Now, the last thing that we need to do is find the restrictions. What are those restrictions? When I'm done this, by the way, I'm going to stop the class and I won't have the homework right away, so you have a few minutes to kind of gather your thoughts. You're not going to leave, though. You have to wait until the bell goes. But don't start the homework that I put in the calendar yet. Don't. Okay. So, Atifa thinks she has some restrictions for us. By the way, we can't reduce this anymore. That's done. What is or what are the restrictions? Go ahead, please. M can be equal to 1, I agree. Negative 2, negative 2, negative 2. I don't see an issue with negative 2. But I know why you got that. I think I know why you got that. I don't see an issue with negative 2. I agree with 1. I agree with 1, 100%. What other value are we going to have a problem with, though? Go ahead. Say it again. No. No. Let's see if we can fix this. Yes. Sorry. Is there a 0 there? Okay, there is a 0 there because of this, right? Right here, if we put 0 into this, we're going to get a 0 on the bottom. So I'm going to agree with that m can't be 0. Yes, I'm going to agree with that. There is another number, though, that nobody has come up with yet. Yes. Thank you. Negative 2 over 3 is 1. But there's another one. It's plus and minus. Negative 2 over 3. Because of the 3m plus 2 and the 3m minus 2, that's where that 2 over 3 comes from. Set those both equal to 0. Use a zero product law. I think we covered them all. I'll double check here, see if we did. Yeah, looks like we have. Looks like we have. All right, you have approximately, I'm being so generous, you have about a minute. Yes. Yes, yes, yes. So the easiest way for me to explain it is to take one of these. See this 9m squared minus 4? That factored into 3m plus 2 and 3m minus 2. Use a zero product law. 3m plus 2 and 3m minus 2, set it equal to 0. Zero product law says if that's true, set each of these equal to 0. So 3m plus 2 equals 0. If you solve this, you get that m is equal to minus 2 over 3. Right? And the same thing would happen over here. 3m minus 2 equals 0. If you solve, m is equal to 2 over 3. So it's plus and minus 2 over 3. Okay? Yes, Jay? Because you factored out an m, remember? Okay.